Yeah, I think he's due to start recording at about 12:15. So, yeah, if you could start the hammering and the drilling then. Yeah, just make sure it's loud today. Okay? Alright, thank you. Bye-bye. Oh, hello and welcome to Friday's edition of Cracking the Cryptic, where today we've got a puzzle by a Spartacus. Now, this puzzle only it's only been released about 2 or 3 days ago. We've already had several recommendations to do it because apparently it is a thing of absolutely magnificent beauty, and it also happens to be propitious in terms of today's date. Because this is the 11th wedding anniversary of a Spartacus and his wife, and it is a tribute to his wife. And it's also the red line here in the grid is a sort of ambigram. There goes Maverick. An ambigram, of course, is some sort of visual pun, usually based around letters. A Spartacus' real name has the initial A, and you can see it sort of looks like an A here. That's an A with the cross there. His wife's initial is N, and I think this, if you look at it carefully, that looks a bit like an N to me anyway. Sort of like that. And then this is an infinity sign. Or even this might be an infinity sign, but either way, there might be two infinity signs. So A plus N infinity. It's a lovely thought, and what an incredible looking Sudoku. If you look at this, we've just got this line, which is basically a palindrome line with another constraint on it, and some Kropki dots, and that's all we get. And apparently, we can solve the puzzle. So I'm looking forward to trying this. And I'll read you the rules in just a moment. Before I do that, yesterday, for our patrons of the channel over on Patreon, we released this Sudoku Extravaganza by Jovial, and many of you have spent many of the hours between then and now solving it. We've had so many emails saying I've spent the last 9 hours on this non-stop, and lots of correct solutions. Very well done. If you've got to the end of puzzle 20, that is superb solving, and all of the plaudits have been lovely to read indeed, as we expected. So do have a go at it. If you're a patron of the channel, just go over to Patreon, upload the first puzzle, work through it. You'll then get the link for the second puzzle, work through that, etc. until you get to puzzle 20. And if you do get to the end of puzzle 20, send us the solution and you'll be eligible for this incredible handmade cushion stroke pillow that's been made for us by Anita Berge. Anita, of course, goes by the pseudonym Alakin over on Discord. So yeah, it's all good stuff, and we are very thrilled indeed to have published it, I can tell you. Other than that, oh yeah, how do you become a patron? Click the link there. I'll try and remember to put it on the screen. It's just a couple of bucks a month, and it helps support the channel. Now, what are the rules of the puzzle? Let me read them to you. Normal Sudoku rules apply. Cells separated by a white dot must contain consecutive digits. So normal Kropki rules for white dots. So if that was a 6, that would have to be a 5 or a 7 to be consecutive. So that's how white dots work. Cells separated by a black dot must contain digits in the ratio of 1 to 2. So this black dot, for example, could be 3, 6 or 4, 8. It sounds like there's some sort of air show going on outside my window. Or 1, 2. 1, 2 would work, or 2, 4, I suppose that would also work. So there are various ways of filling black Kropki dots such that they have the ratio of 1 to 2. Not all dots are given. So that means, for example, let's look at this domino. It's absolutely fine for this to contain a 2 and a 4. Just because you could put a black dot between these digits doesn't mean there needs to be a black dot. So it's just positive information basically regarding the black dots. Now the red line. Now the red line is where the interesting stuff starts. The red line is a palindrome for which the start cell and end cell must be determined. The line must read the same in either direction. So what that means is that, let's say we found this square was the start of the palindrome. Make that blue. And let's say it went this way, so it's going to go wee up here, round here, back through there, back through here, back through here, back to this square, back over here, all round here. I probably shouldn't have picked this cell. I think it's actually, let's not pick that cell. It's a bit complicated. Let's pick that square. So let's imagine this square was the start of the palindrome, and let's imagine that square was the end of the palindrome. So the palindrome's starting in this direction, and let's imagine that was a fact, I can see I've made a mistake here as well, but let's just go with it. Let's say the palindrome started 1, 2, 3, 4 in that direction, all the way until it got to the green line. Well, in order for the palindrome to read the same in both directions, obviously from this direction it would have to read 1, 2, 3 and 4, and you can immediately see I've made a mistake because I've got 2 1s in box 7. But that is in theory. Just to ignore the sort of Sudoku aspects, that's how the palindrome should work. It needs to read the same forwards and backwards. And no, oh, hang on, what does that say? Neighbouring digits along the line cannot be further apart in value than 2 steps. Right, okay, so a 5 would need to be next to a 3, 4, 5, 6 or 7. Right, that's interesting. So we've got, as we move up and down the palindrome, we've got to make sure that the next digit along is within 2 of this one. So that could actually be a 5, that could repeat because that's not in the same box, row or column as this 5. Or it could be a 4, that's within 1, a 3 is within 2. It couldn't be a 2 because that would be 3 steps away. And there's one more rule, which is, right, for this purpose 1 and 9 are considered to be consecutive, e.g. a 1 can have the digits 8, 9, 1, 2 or 3 as its neighbours along the line. Wow. Okay, so let's think about that for a second. So basically, normally, if you drop down from the number 1, you would hit the number 0. In this puzzle, we have to view it as us hitting the number 9 again. So it's sort of 1 and 9 are cyclical. So in order for something to be within 2 steps of 1, it could obviously be a 2 or a 3, or it could be a 9 or an 8 in the other direction, or indeed, on that particular junction, a 1. So that's how the rules work. Interesting stuff. Not a lot of information. Well, there'll be lots of information once we get numbers on the palindrome line, but until we do, it's probably going to be quite difficult. Let's get rid of those colours. And now, do have a go. The way to play is to click the link under the video as usual. Long introduction today. Now I get to play. Let's get cracking. Forgive the long introduction. I think it's worth going through the rules to make sure we all understand them, especially me. Now, I was about to say something that was going to be wrong, I think. I was about to say that the palindrome is an odd length because I was looking at this square. So I'm noticing that the palindrome is symmetrical. And as therefore I was looking at that square and thinking, okay, well there must be the same number of red cells to the left of it as there are to the right of it. Therefore, if this was X numbers, if this to the left there were X cells, to the right there must be X cells, so that's 2X plus this cell would give us an odd number of cells, but that cell is actually on the palindrome twice, isn't it? So do I have to count that twice in that count? I think that does make sense to me. So I suspect that the palindrome contains an even number of cells. I think we're going to actually have to know how many cells it contains. I think. I'm not sure. Where is the best place to start? Well, I think we'll start from somewhere not interrupted by the fact it sort of goes through a cell twice. Let's start there and work out how many cells the palindrome's got. So let's start here and go left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That one is revisited. 15, 16, 17, 18, 19. That's revisited. 20, 21, 22, 23, 24. That's revisited. 25, 26. And then we get back to the start. So I think there are 26. So there are an even number of cells on it. And there's one for every letter of the alphabet, which is interesting. So we've got 26 cells. So I think what we're going to have to do here is somehow figure out there are 26 cells on the palindrome. Yeah, okay. That's, I think what we're going to have to do here is to somehow, we obviously don't know where the start and end go, but we do know something about the start and end of the palindrome, because we know the start and the end of the palindrome contain the same digit. So there's lots of cells on this palindrome that we can immediately say are not the start and end cells of the palindrome. For example, those two obviously cannot be the start and the end, because if that's a 1, by the time you get round here and reach the end, this needs to be a 1, so the palindrome reads the same in the other direction. So you can never have the start and the end of the palindrome in the same column, in the same row, or actually in the same box. So you can't even have that arrangement. So, right, oh, this is very interesting already, actually. That means that the only places that the start and end of this palindrome can be are cells separated across a box that aren't in the same row or column. So cells like those two. So these two could be the start and the end. Those two could be the start and the end. These two could be the start and the end. Oh, I'm going to have to colour this, aren't I? This is going to get confusing. And I may have to close my window in a minute to stop you having to listen to the air show outside my window. Those two squares, they are definitely diagonally across a box. Those two squares, oh, it's symmetrical, so it must be those two as well. Right, okay, so yellow there, let's make those orange. So I think these, unless I've missed 1 or 2, are the only possible cells that can be the start and end of the palindrome. But yeah, okay. And what I'm thinking is we can limit which ones of these are possible using the fact that there is a middle to this palindrome. Because if we think about an even length of palindrome, let's imagine this was the palindrome. Let's simplify it somewhat. This is now our palindrome. And let's ignore Sudoku rules for a moment and think about how we would fill this even length palindrome. Let's do it like that. That's undoubtedly a legitimate palindrome. It reads the same from this direction and from this direction. So the middle two cells of a palindrome of even length are obviously the same digit. So that means that on this palindrome, which is of length 26, the 13th and 14th cell are the same digit. And that means that when we... Yeah, so that means that when we... If say we take this as an example, let's say we're trying to prove that this is the start or the end of the palindrome. If we count the 13th and the 14th cell here and we end up, I don't know, on those two squares, then we would know that this was not the start and end of the palindrome, because the middle cells could not be the same digit, because these would be in the same column of the Sudoku. So this at least gives us a way, hopefully, of narrowing these down. Now, in fact, I'm very suspicious. I think this or this are likely to be. These look too symmetrical. Let's try it anyway. So let's try blue as the start and the end. We'll make this the start. I don't think it matters which is the start and which is the end, because they're sort of ambivalent. But so this is position 1, 2, 3, 4, 5. Then we're going that way, aren't we? 6, 7, 8, 9, 10, 11, 12, 13. So this is not going to work, because unless I've really messed up here, this square is going to be the 14th cell on the palindrome, and that's going to be in the same column. Let's double check it. So from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Perfect. It is this one. So we can now rule this out. This is impossible. And we can rule this one out as well, because the ambigram is symmetrical. The equivalent of these two squares, the middle squares from these two squares on the palindrome, are going to be those two squares. And you can't make these two the same digit. So this is beautiful. We can get rid of these. Oh, and in fact, the only problem with this is that we've got this arrangement, which all looks very symmetrical. In fact, the whole puzzle looks symmetrical. In fact, the whole puzzle... Wow. Almost the whole puzzle is symmetrical, apart from this. This is unbelievable. So the only thing breaking the symmetry of the puzzle, and bear in mind this puzzle must have a unique solution, it can't have two solutions, is the fact that this domino and this domino are different. This and this are symmetrical, and both black Kropki dots, this and this are symmetrical, this and this are symmetrical. This and this are symmetrical. The ambigram is symmetrical. So there's some disambiguation to do with this black Kropki dot and this white Kropki dot. So presumably, somehow, one of these options is going to map onto these somehow and fix it. Let's try this one. So which way should we go? Let's say we're going this way. So we'll make this the first position. So 1, 2, 3, 4, 5, 6, 7, then 8, 9, 10, 11, 12, 13, 14. Oh, hang on, I've gone too far, haven't I? Oh, I had to go to 13. I think that's going to be that one. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It is that one. Oh. So this one maps onto that one, which means this one maps onto that. Oh, right. That's very interesting. So now I've suddenly realised that because this is... Yeah, the start and the end of the palindrome is a little bit of a misnomer here, isn't it? Because if we view this as the start and the end, we get that as the middle. But if I view that as the start and the end, I'm going to get that as the middle. So in fact, we're never going to know what the start and the end is, and which ones the middle are, because they're sort of, we can't tell. But now at least what we've done is we've reduced the puzzle to two possibilities now. Either this collection of digits forms the start, end and middle of the palindrome, or this collection of digits does. So, the only other problem I've got with this though is that I haven't used these at all. So perhaps I've got to... Let's get rid of these. I think what we're going to have to do is we're going to have to colour until we reach these things, and hopefully we will find a problem, or not. But I can't see a way without colouring of telling whether this is correct, or whether this is correct or this is correct. Let me just think about this for a second, sorry. Let me read the rules again as well. The line must read the same in either direction. Neighbouring digits cannot be further apart than 2. So, oh, I see. I hadn't appreciated something about this. Black Kropki dots are really restricted. Black Kropki dots are massively restricted. You can't put 4, 8 on the black Kropki dot here, because if you do, 4 and 8 are too far apart. They have to be within 2 of each other. So 3 and 6 doesn't work either. That's within 3, not within 2. So a black Kropki dot in this puzzle is either 2 and 4, or it's 1 and 2. That's huge. Okay, so this is what I've missed, I think. So let's do that and have a look at it. 1, 2 and 4. So that this one to this one, no, you see, it can still be think one of those, well, they could be the same digit. That's the point, isn't it? It doesn't matter. Okay, sorry. I'm just trying to figure out whether this actually is something I can use. Don't know. Or maybe now I'm thinking about the middle cell as well. Because if you think about any digit, let's try and put a 5 in the middle. We now can see from the pattern here that this digit, this digit, this digit, and this digit all have to be within the rules consecutive with 5, in the sense they have to be within two of it. So these 4 digits here would have to be 4, 6, 3, 7 in some order. And that, whatever you put in the middle, that's going to be the case. There's going to only be 4 digits that are eligible to go into the corner squares of the middle box. But until, the problem is that because we've got sequencing, the sense that one can go downwards as well as upwards, we don't actually know anything about what that digit is. Sorry, that's not useful. This isn't useful. I'm just trying to get my head around how to do this. I think what we've got to do is continue the colouring. And hopefully, somehow, this will map to something that looks impossible. And I think it's either going to be this or this that's going to have to disambiguate whatever's going on. So let's figure this out. We've got a colour, so that square can be orange, which means, now let's get this right, this is going to go round there, so that means this square is orange, I think. Then this square can be yellow, which means that square's yellow, which means this square is red, which means that square can be red, which means that square can be blue, that square can be blue. So it's already quite interesting, actually, because look here. This square is yellow and that square is yellow, so that's got to be a 1, 2 or a 4. So if we can prove that that has to be a 1, 2 or 4, we'd have broken the puzzle. And that's exactly what I want to do. Blue here goes here. So it's all going to be about these black Kropke dots, I think. This is where we have to focus our attention. Now this square is the same as that square. Running out of colours a bit here. I really am running out of colours. Have I used green? Yes. Yellow? Yes. Oh, I'm going to have to use greys, I think. Right, grey can go in. So that's 1, 2 or 4. Whoopsie, I want that to be grey. 1, 2 or 4. This one's got to be dark grey. Oh no, it doesn't. I was about to say that's going to have to be dark grey, but no, look at the next digit on the Kropke dot. It's green, so it can be green again. And therefore green, we don't know what green is. Oh. Okay, well the next digit will have to be grey. So then after green, we go to this digit, which is now grey. So this is a 1, 2 or a 4. We go to this digit, which will have to be black. That's my last colour, which means that digit is black. So again, we've got 1s, 2s and 4s in the column. Oh, this is it. Right, it's broken. It's broken. It's broken because now look at the next digit on the Kropke dot. Not on the Kropke dot, on the red line. I'm going colour crazy. The next digit is yellow, and that goes here. And now I've got too many 1s, 2s, and 4s in column 7. That is weird. That is so strange. Yeah, in fact, those have to be consecutive, don't they? So they have to be 1s and 2s. So that's got to be a 4, and that's got to be a 4, and you get clashing 4s in the column. Wow. Wow. Now the thing I'm just pausing about here is that somehow this pattern that we've just identified, which was breaking, once we flip the puzzle over and we make these the starts and ends, this has got to somehow work. I'm just trying to work out in my head why it's going to work. It's obviously something to do with these two Kropki dots. So the fact that this is mirroring here, so in the other version, yeah, I think I can see what's going to happen. I'm going to have degrees of freedom because I can use the white Kropki dot to escape. That is weird. That is absolutely bizarre. What an idea this is from a Spartacus. Good grief. Now, this is a bit depressing, though, because what I have to do now is this. Oops. So after 26 minutes, I have got nothing. But I have knowledge. I have knowledge I didn't have before. These are the key squares now. This is what we have learned. So hopefully we can now figure something out from here. And I'm expecting the magic or the difficulty to be in these cells. So these are the cells we're going to have to keep an eye on, and hopefully they are going to reveal the secrets of the puzzle to us. So let's do it. So we're going to go yellow in those directions, then we'll go green as the next digit, I suppose, and then we can go purple. Now we're going that way, aren't we? So purple. Orange. We're almost hitting, I think, oh yeah, I'll tell you what I should do as well. I should label all my black Kropki dots as well, because we know they're 1s, 2s and 4s. So now this has become a 1, 2 or a 4. And we're about to get to some interesting stuff, aren't we, around, yeah, because the next digit is those two digits have to be the same. Have I used all my primary colours? I have. Yes, I have. I've got to go grey again. No jokes, please. Now the next digit is red, look. So that means that's got to be red. And therefore this square has got to be a 1, 2 or a 4. Which might be interesting. Is that interesting somehow? Not exactly saying how. Now the next digit is these two. Oh, here we go. Here we go. So now this is the equivalent of the logic we did on the other side. This is going to have to be a 1, 2 pair, isn't it? Because I can see the next digit on the red line from this direction is this square, which I'll make dark grey, and this square is dark grey. Now this one will then have to be black, this one will have to be black, but look now, this is mapping a black Kropki dot onto a white Kropki dot. So we need these two to be consecutive, they've got to be 1 and 2, which means that's got to be 1 and 2. Which means red's 4. Red's 4. This red is here. It's got to be a 4. It can't be a 1 or a 2. I've got a digit in the grid. 4, 4, 4, 2, 1. Oh, look. 1, 2. 1, 2. I've got a whole flurry of digits in the grid. Good grief, this is exciting. Now, is the puzzle broken in this position? The answer is no. Right, this is it. This is how it differs. This square, which in the other version had to be a black Kropki dot square, so it had to be a 1, 2 or a 4, and was broken, is not broken in this version. Because it's a white Kropki dot square, and therefore it has flexibility to be any number. Now, hang on, we've got to carry on here, because the next digit after the 1, look, is a green digit, so that's green. And then the next digit, oh, I've run out of colours, but those two squares are the same. And then the next digit is yellow, so then that's a yellow square. Yeah, the other thing I'm going to have to watch out for here, I was just thinking about this now. I was about to write this square in as yellow. But is it possible yellow could be black? Ah! See, by Sudoku this should be yellow. But if yellow was black, then that wouldn't necessarily need to be the case. So I don't think I do know that at the moment. So it's just these two squares which are colourless. I don't know what to do about that. I suppose I could multicolour them. That's probably a sensible idea. Let's multicolour them with those two. So these are the same. Okay. And have we somehow now... Have we somehow solved the puzzle? I'm not sure. This square is green, but it could be... It has to be consecutive with 1, but it could be 8 or 9, which is the problem. So that can be 8, 9, or even 3, which is absolutely appalling. That one can be 3, 8, 9. This one can be 3, 8, 9. So... 1? I'm not actually sure. I have to be honest, I'm not sure what I should be looking at now. Oh, hang on. I've got those two are the same colour. Is that right? So it's a bit annoying that these are different shades of grey, but I think, the way to do it actually is to use the orange. I've just noticed orange is 1, so that's a 1, that is a 2. So these two colours are now the same colour. So I should actually correct those then. They can be the same colour. Now, does that matter for the middle box? The answer is maybe not. There's a 2 in one of those squares. 1 in the middle box. Oh, this is really confusing. What? Hang on. 2 definitely can't be yellow, but I think 1 can be yellow. So 1's got to be in one of those squares. Can this be a 1? Don't know. Don't know. Right, so have I done all my black Kropki dots? I have. Have I done all my white Kropki dots? Most certainly not. So we're going to have to work on the white Kropki dots, I feel. And where is going to be the best place to start to do that? Maybe this one, purple. I have a feeling we can do more with Sudoku as well. I'm just trying to see where there might be an easy win. Oh, because 1 now is also... Oh, this is getting shockingly confusing. But 1 now doesn't need to be black anymore because it could be orange. Those are all the same digit. So 1 down here is in one of those squares. It's really confusing as well because normally when you put 1, of course, on a white Kropki dot, it can only go to being a 2, but here it can go to being lots of other things as well. Right, let's look at this square. So this square has to be, it cannot be 1, 2 or 4. It's got to be 3, because it's got to be next consecutive with 1, 8 or 9. This is 3, 8 or 9. This is 3, 8 or 9. And this is on a white Kropki dot, so 3 is now impossible, because 3 is not consecutive with 8 or 9, even in the mad weirdity world that we're now living in. So this is now an 8-9 pair. That feels important. Is it, though? Yeah, this is now an 8 or a 9. So green is now 8 or 9. Has that done something to me? Yellow. Oh, yellow can't be a 1 because of this 1 seeing that 1. Good grief. Okay, so this is a 1 and this is a 2 using Sudoku. Now 2 we know we can make dark grey, 1 we can make orange, 1, oh, can 1, no, 1 can't be this funny colour. In fact, this funny colour can now not be that funny colour. We can make that a different colour. We can make that black. 1 can't be black because black's in the box with 1. So 1 is here. Lovely. 1 is here in box 6, which means 1... Can 1 be blue? No, it can't. So 1 is here in box 9. Good grief. And 1 is in one of those 2 squares in box 7. Yellow now can't be 1, so yellow has to go there by Sudoku. Yellow's in one of these 2 squares. These 2 digits have to be consecutive. I don't know where to look. This is 8, 9. 4, look, I suppose we could look at 4. 4 has to be in one of those 2 cells. And 4 has to be in one of these 2 squares. Green has to be in one of those 2 squares, so green has to be in one of these 2 squares. The symmetry is absolutely profound. So literally, the moment you find one deduction, you should be looking at the symmetrical counterpart, trying to find an equivalent deduction. 2 is not yellow, so this is a 2, which means this is a 2, providing 2 can't be blue, which it can't, so that's a 2. This is a aha, I've got a 2 in the corner. Not quite good enough for a song, but it still must be interesting. I've got to be careful though, because this has got all sorts of options, hasn't it? Although it can't be 4, it can't be 1, and it can't be 9. So it doesn't have all sorts of options. That's simply got to be a 3. Which is, well, that feels very important, but actually I don't know anything about 3. So it's sort of nice to know, but not nice to know. What about that square then? So this is yellow. But the problem with yellow is so if this was 9, this would have as its options only 7, I think. Because 1 and 2 would not be available. So if this is 8, this can go down to 6. But it can't. So this is a 6 or a 7. So yellow is 6 or 7. Let's put that in. But yellow... here you go. Yellow has to be consecutive with red. So that can't be 7 because 4 and 7 aren't close enough to each other. That's a 6. Now this being a 6 forces this to be an 8, and that's a 9. Green is now 8. Purple is 9. 6 is consecutive with 8, so that's fine. So we now know those 2 squares have to be the other consecutive digits with 6, which are 5 and 7. And look, there's an 8 here. So these 2, this can't be 5. It's not close enough to 8. So that's 7. That's 5. Blue is 5, so that's 5. This is 7. It is consecutive with yellow, so that's good. That domino might be useful now, which has got to be either... Can't be 9, look. So there's no 9 on this domino. So where does 9... So where does 9 go in the row? 9 has to go there, I think. These squares are from 3, 4 and 5, which makes this a 3. Oopsie. That a 3 by Sudoku. 3 goes with its friend over there. This is a 4, 5 pair. This is an 8, 9 pair. 9 is in one of those 2 squares by Sudoku. These 2 squares are 3 and 6. Oh no, 3 and 9, sorry. Which places the 8, which places the 9. 9 has its own colour, so let's give it to it. Green has its own colour. Well, no, 8 has its own colour. Sorry, I misspoke. 4 has its own colour, but I don't know which of those is 4, as does 5. What about these squares? So these squares have got to be 3, 7 and 8. Well, the only ones of those that are consecutive are 7 and 8. That is true. I'm just checking. Yeah, that is true. So 8 and 7, because you've got to... Oh no, the other thing is I've got to bear in mind that the consecutive rule isn't... Yeah, that only applies on the line, which I've done. So I can forget about the sort of values being within 2 of each other now, which is a bit of a relief. So that's 8. 7 is a dark colour. Those 2 squares have got to be 4 and 5, which I don't seem to be able to do. Use the knight's move there. No, I'm only joking. There's no knight's move, I don't think. 5. Where does 5 go in box 7? It's got to go there. That gets a blue 5 into the grid. This has got to be 1 and 7, so that's a 7. That's a 1. That gets its own colour, of course. The 1 probably gets its own colour. It does. That fixes the 1 at the top of the grid as well. Lovely. This, it looks very congested, doesn't it? That's a 6-7 pair. Can't see how to disambiguate the 4 and the 5 yet. But we've still got some crop key dots to use, so let's try and use them. What about this one? This one can't have a 4 on it because you can't make this square 3 or 5. So that's not 4. This is 4. And 4 is a red number. So this is either 7, 8 or 9. And it must have an 8 on it, therefore. Is that right? I think it's right. It is right. So the 8 must go here. And this has got to be a 7 or a 9. And 8 is green. And 4 is in one of those 2 squares by Sudoku. And 1s. Have we done all the 1s in the grid? We have done every single one. That's nice. 2s. We've done many 2s, but not all of them. But there are 4 2s looking at box 1 of the grid. So that is a 2. So all the 2s are now done. Why is that 7 highlighted in that colour? That shouldn't be that. That should be, I think that's meant to be black. 3s then. We know very little about 3s. This digit is fairly simple. Sorry, I didn't spot that. That digit's now become simple. That's got to be 8 as well. So 8, lovely. So this is the final 8 in the grid, I think, and that's going to give us the 9 and the 4 as well, which gives us the 4 and the 5. So that feels like progress. What colour was 9? 9 was purple, and 4 had its own colour. I know that, it was red. 5 had its own colour, it was blue. So these squares here have got to be 3, 6 and 7. Which we can probably do, but I can't quite see how. That can't be 7. So this is 3, 6 or 7. We've not done this crop key dot, which actually I'm a bit worried about because this seems to have a lot of options. This crop key dot, you can't put 3 on this crop key dot because it couldn't have 2 or 4 on it. So the 3 is in one of those 2 squares. Oh, whoopsie. Corner pencil mark. So 3. 3's in one of those 2 squares. So these squares are from 5, 6 and 7. Which means there's a 6 on the crop key dot. Which places, lovely, that places 6 in row 3, look. Use the fact that we know the 6 positions in box 1 and box 3. So the 6 can't be here, can't be in those squares, so let's get rid of it from there in fact. That's not 6 anymore as a result of that logic. And the 6 is in one of these 2 squares in row 3, well it's got to be here then. And that square is now yellow, which means this square is yellow. By our old friend Sudoku, which gives me a 3 here. And that gives me a 7 and a 6, which means there's no 7 on that crop key dot at the top. Oh, we could have used uniqueness there to prove that, but I didn't do it. This now has got to be a 7. which makes this one a 3. 7s have their own colour, so we should give it to them. So I think 3 is the unlucky colour, isn't it? That's not going to get awarded anything. What about this row? That needs 4s and 5s. Bobbins is what we say in that respect. I can't do it. But that does give me this digit. That's now got to be a 9 by Sudoku. Yeah, we could have got that before if we'd looked for it. 9 is in one of those squares. 3, 7. 3, 7, 9. Okay, 3, 5, 9 in this column. That's got to be 3 or 5. This has got, that's got to be 3 or 5. So the question is, where does the 9 go in this column, actually? I think it can only go here. So that becomes a 3. This becomes purple. That becomes, that's a 7 because of the 9 here, look. That gets its own colour. Maverick flies past ever lower. This becomes a 9. That's not 9, therefore. Whoopsie. And hopefully we can now do this Kropki dot, or at least get closer to being able to do it. 6, 7 here. So these are 3, 4, and 5. And we can get rid of 4 from that one. Yeah, I think it's going to be this Kropki dot that finishes the puzzle off. So, what can we put on this? If this is 5, this would have to be 6 or 4. It means it has to be 4 because it can't be 6. If this is 3, it's got to be 2 or 4. So this is always 4. That's what we're learning. Still doesn't tell us what this is, but it gives us that digit, and that's nice. So now we've got a 3, 5 pair here, which places this one as 6, this one as 5, gives us the 6 and the 7. Places a 7 here by Sudoku. We should colour all these things in just to be consistent. Oh no, am I going to get a deadly pattern here? I've got a horrible feeling about this. Have I made a mistake? Oh no. 9 goes here. Ah, no, that's pushing this to be a 5. Oh, thank goodness for that. 5 and 3 go in. This becomes a 3. This becomes a 3, and this becomes a 5. And yes, I do know that I've not coloured everything in, so I will do that before I click the button that's going to tell us whether we've got a solution or not. There you go. Just the 3's uncoloured. Click tick. Yay. That is just genius, that puzzle. It really is. What I absolutely loved about this, and in fact, I think to show you what I really loved, I'm almost tempted to start the puzzle again, because I just loved the fact that it was like the first bit of the puzzle was like a puzzle on its own. It was nothing really to do with Sudoku. What we had to do is to appreciate the geometry of the palindrome line and how it worked, and the fact that it had to have a middle, and the fact that the middle had to have similar digits on it, and therefore we were able to pinpoint that either these squares were the starts and middles or these squares were the starts and middles. And from that, it's just amazing that Spartacus has managed to come up with such an elegant arrangement of Kropki dots that actually it breaks when you look at it from this way round. And it broke in that column, didn't it? And then when you do the symmetrical logic, because this one is not a black Kropki dot, this square in particular somehow works and actually allows you to make enough progress to finish the puzzle uniquely. I mean, Spartacus, take a bow. I hope that your wife had a go at this puzzle. I hope that she admired it as much as I do. It really is stunning. Thank you so much for watching. I hope you enjoyed a bit of a chromatic festival today. And we'll be back later with another edition of Cracking the Cryptic.